Have you ever gazed at a mother bird tirelessly feeding her chicks and wondered, why does she work so hard for these demanding little creatures? Or perhaps you've marveled at the intricate dance of cooperation in an ant colony and thought, how did such selfless behavior evolve? These questions strike at the heart of one of biology's most profound mysteries, the origins of altruism in a world shaped by the merciless forces of evolution. On the flip side, have you ever witnessed the ruthless competition in nature, predators stalking their prey, plants strangling each other for sunlight, and pondered how such selfishness could coexist with acts of apparent kindness? These seemingly contradictory behaviors have puzzled scientists and philosophers for centuries. But what if I told you that there's a groundbreaking theory that not only explains these paradoxes but also revolutionizes our understanding of life itself? A theory so powerful that it has reshaped the landscape of evolutionary biology and sparked heated debates that continue to this day. Welcome to The Selfish Gene, Unraveling the Mysteries of Evolution. I'm your host, and today we're diving deep into the revolutionary ideas presented in Richard Dawkins's landmark book, The Selfish Gene. Published in 1976, this work turned the world of evolutionary biology on its head and continues to influence how we think about life, behavior, and even culture. Before we plunge into the fascinating world of selfish genes, let's take a moment to appreciate the impact of this book. The Selfish Gene didn't just make waves in academic circles, it created a tsunami that washed over popular culture, changing how millions of people understand evolution and their place in the natural world. Richard Dawkins, a British evolutionary biologist, wrote this book early in his career, and it catapulted him to fame, but more importantly, it introduced a radical new way of thinking about evolution that has stood the test of time and scientific scrutiny for nearly half a century. The ideas in The Selfish Gene have influenced fields as diverse as psychology, economics, and computer science. They've sparked philosophical debates about the nature of life and consciousness, and they've provided a framework for understanding behaviors that had long puzzled scientists, from the sacrifice of worker bees to the complexities of human altruism. But what exactly are these revolutionary ideas? How do they change our understanding of life and evolution? And why have they stirred up so much controversy? These are the questions we'll be exploring in today's episode. Let's start by looking at the central concept of the selfish gene. The idea that genes, not individuals or species, are the fundamental unit of natural selection. Now you might be thinking, well, wait a minute, I learned in school that evolution acts on individuals or maybe even groups. And you'd be right. That was the prevailing view for a long time. Scientists focused on how individual organisms adapted to their environments and passed on beneficial traits to their offspring. But Dawkins argued that this view misses the fundamental nature of evolution. He proposed that we need to zoom in even further to the level of genes themselves. According to Dawkins, it's the genes that are truly selfish, not in a conscious or moral sense, but in the sense that they are the entities that persist through generations, replicating themselves and spreading through populations. Let's break this down with an example. Imagine a gene that causes an animal to have slightly better camouflage. This gene doesn't want anything in a conscious sense, but the animals carrying this gene are more likely to survive and reproduce. As a result, more copies of this gene will be passed on to the next generation. Over time, this gene will become more common in the population. Now here's where it gets interesting. From the gene's perspective, remember, we're speaking metaphorically here, the individual animal is just a vehicle, a temporary host that the gene uses to make copies of itself. The gene doesn't care about the individual animal beyond its ability to survive and reproduce. This shift in perspective might seem subtle, but its implications are profound. It explains why organisms often behave in ways that seem to go against their individual interests. For example, why would a worker bee sacrifice its life to defend the hive? It doesn't make sense from the individual bee's perspective, but it makes perfect sense from the perspective of the genes. The worker bee is sterile, but by defending the hive, it's protecting its sisters who carry many of the same genes. Now I can almost hear you thinking, but wait, doesn't this mean that all organisms should be ruthlessly selfish? After all, if genes are selfish, shouldn't the organisms they build be selfish too? This brings us to one of the most fascinating aspects of the selfish gene theory: how selfish genes can lead to both selfish and altruistic behaviors. And to understand this, we need to explore some key concepts: kin selection, reciprocal altruism, and the idea of inclusive fitness. Let's start with kin selection. The basic idea is simple. Genes can spread not just through an organism's own offspring, but also through the offspring of close relatives. This is because close relatives share a high proportion of their genes. Imagine a gene that causes an animal to share food with its siblings. This gene might reduce the individual animal's chances of survival slightly, but it greatly increases the survival chances of its siblings. Since siblings share, on average, 50% of their genes, this food-sharing gene could spread through the population, even though it sometimes harms the individual carrying it. This concept explains a wide range of behaviors in nature. It's why parents care for their young, why siblings often cooperate, and why many social insects like ants and bees form complex cooperative societies. But what about altruism between unrelated individuals? This is where reciprocal altruism comes in. The idea here is that organisms can benefit from helping others if there's a high chance that the favor will be returned in the future. Think about vampire bats. These bats need to feed on blood every night to survive. Sometimes a bat will fail to find a meal. In these situations, other bats will often regurgitate some of their blood meal to feed the unsuccessful bat. This seems altruistic, but it makes sense when you consider that the roles might be reversed in the future. The bat that shares today might be the one in need tomorrow. This kind of reciprocal altruism can evolve when there are repeated interactions between individuals, and when there's a way to keep track of who has helped whom. In human societies, we see this principle at work in everything from friendship to international diplomacy. Now let's take a moment to appreciate how revolutionary these ideas were and still are. They provide a unified explanation for a vast range of behaviors in nature, from the self-sacrifice of a worker bee to the cooperation we see in human societies. But the implications go even further. The selfish gene perspective helps us understand why organisms age and die, why there are conflicts between parents and offspring, and even why sexual reproduction exists. Take aging, for example. From an individual's perspective, it seems like natural selection should favor organisms that live forever. But from a gene's perspective, once an organism has reproduced and raised its offspring, it becomes less useful as a vehicle. Genes that allow for a longer reproductive lifespan will be favored, but there's little selective pressure for longevity beyond that point. Or consider conflicts between parents and offspring. Both share genes, so you might expect their interests to align perfectly, but each offspring carries only 50% of each parent's genes, while carrying 100% of its own. This means that offspring will often want more resources from their parents than the parents are selected to give, leading to a subtle evolutionary tug-of-war. Now that we've explored how the selfish gene concept explains behavior, let's zoom out and consider one of Dawkins' most intriguing ideas: the extended phenotype. In biology, the phenotype refers to the observable characteristics of an organism, things like eye color, height, or behavior. These are the physical expressions of an organism's genes. But Dawkins argued that we shouldn't limit our thinking to just the organism's body. Genes can have effects that extend far into the environment. Consider a beaver's dam. It's not part of the beaver's body, but it's clearly an expression of the beaver's genes. The genes that cause beavers to build dams have effects that ripple out into the environment, changing river ecosystems and affecting countless other organisms. Or think about a spider's web. The web isn't part of the spider's body, but it's just as much an expression of the spider's genes as its 8 legs. The genes that code for web-building behavior are selected based on how well the resulting webs catch insects. This concept of the extended phenotype forces us to think about the boundaries of an organism in a new way. Where does the influence of an organism's genes truly end? But the extended phenotype isn't just about structures built by animals. It also includes more subtle influences. For example, some parasites manipulate their host's behavior in ways that help the parasite spread. There's a fungus that infects ants and causes them to climb to the top of grass blades, where they're more likely to be eaten by sheep, the next host in the fungus's life cycle. From the perspective of the extended phenotype, the ant's climbing behavior is part of the fungus's phenotype, not the ant's. This idea of the extended phenotype is more than just a curiosity. It's a powerful tool for understanding the intricate web of relationships in ecosystems. It shows us how genes can have far-reaching effects, influencing not just the organisms they're in, but entire environments. And it raises some profound questions. If a beaver's dam is part of its extended phenotype, what about the cities humans build, the books we write, the digital environments we create online? How far does our genetic influence extend into the world around us? Now let's shift gears and explore one of the most controversial and thought-provoking ideas to come out of the selfish gene, the concept of memes. Dawkins introduced the term meme as a cultural analogue to genes. Just as genes are replicators in the biological world, memes are replicators in the world of ideas and culture. A meme could be a catchy tune, a fashion trend, a philosophical concept, or even a viral video. The key idea is that memes, like genes, undergo a process of variation, selection, and replication. Memes that are good at getting themselves copied, whether because they're useful, memorable, or simply appealing, spread through populations. Those that aren't good at replicating fade away. This concept provides a new way of thinking about cultural evolution. Just as the selfish gene perspective shifts our focus from individual organisms to genes, the idea of memes shifts our focus from individual humans to the ideas themselves. Consider the spread of a viral video on social media. The video isn't consciously trying to spread itself, just as genes aren't consciously selfish. But videos that are particularly funny, shocking, or emotionally resonant get shared more often, they replicate more successfully. Or think about the evolution of language. Words and grammatical structures that are easy to learn and use tend to persist and spread, while more complex or confusing elements often get simplified or dropped over time. The concept of memes has been hugely influential, inspiring fields like memetics and digital anthropology. It's given us new ways to think about the spread of information in the digital age, the evolution of cultural traditions, and even the nature of consciousness and identity. But it's also been controversial. Critics argue that cultural transmission is more complex than biological transmission, and that the analogy between memes and genes can be misleading. There's also debate about whether memes can truly be considered replicators in the same way genes are. Despite these controversies, the concept of memes has undeniably changed how we think about culture and ideas. It's a powerful reminder of how the principles of evolution can apply beyond the biological realm. Now, as we near the end of our exploration, it's important to address some of the controversies and criticisms surrounding the selfish gene and its ideas. One common misunderstanding is that the book promotes selfishness as a moral good. This is a fundamental misreading. When Dawkins talks about selfish genes, he's not making a moral statement. He's describing the blind process of natural selection which favors genes that are good at getting themselves copied. This process can lead to both selfish and altruistic behaviors in organisms. Another criticism is that the gene-centered view ignores the complexity of biological systems. Some argue that we need to consider higher levels of organization, like organisms and ecosystems, to fully understand evolution. There's also been pushback against the idea of memes, with some arguing that cultural transmission is too complex to be reduced to a simple replicator model. These debates are ongoing, and they highlight the continuing impact and relevance of the selfish gene. Science progresses through debate and refinement of ideas, and Dawkins' work has certainly stimulated plenty of both. It's worth noting that Dawkins himself has refined and expanded on his ideas over the years. In later works, like The Extended Phenotype, he's explored the implications of his theories in greater depth and responded to various criticisms. As we wrap up our journey through the world of the selfish gene, let's take a moment to reflect on the key ideas we've explored. We've seen how shifting our perspective to the level of genes can explain a wide range of biological phenomena, from the sacrifice of worker bees to the complexities of human behavior. We've explored how selfish genes can lead to both selfish and altruistic behaviors in organisms through mechanisms like kin selection and reciprocal altruism. We've considered the concept of the extended phenotype, which challenges us to think about where the influence of an organism's genes truly ends. And we've delved into the idea of memes, which applies evolutionary thinking to the realm of culture and ideas. These concepts have reshaped our understanding of life, behavior, and evolution. They've provided new tools for understanding the world around us and our place in it. But perhaps the most profound impact of the selfish gene is how it changes our perspective on life itself. It reminds us that we are part of the grand, unbroken chain of evolution that stretches back to the very first replicators. Our bodies, our behaviors, even our cultures are the product of this ancient and ongoing process. As we go about our lives, making choices, interacting with others, and navigating the complex world of human society, we carry with us the legacy of billions of years of evolution. The selfish gene perspective doesn't tell us how to live our lives, but it does give us a new lens through which to understand our deepest drives and instincts. So the next time you feel a surge of love for your child, or a twinge of envy at a friend's success, or a desire to help a stranger in need, remember, you're feeling the echo of ancient evolutionary forces shaped by the relentless logic of gene selection. This concludes our exploration of the selfish gene. I hope this episode has piqued your curiosity and inspired you to delve deeper into these fascinating ideas. If you want to explore further, I highly recommend reading the book itself. Dawkins's clear and engaging writing style makes complex concepts accessible and exciting. Remember, you can find a link to purchase The Selfish Gene in the episode description. Whether you choose the print version or the audiobook, you're in for an intellectual adventure that will change how you see the world. Thank you for joining me on this journey through one of the most influential scientific works of the 20th century. Until next time, keep questioning, keep exploring, and remember, your genes may be selfish, but what you do with them is up to you.